Hello everyone, welcome back. So in this video we are going to understand add binary problem, and this is LeetCode problem number 67. Okay, and this is very interesting problem. So let's try to understand. We have given two binary string A and B, and we have to return their sum as a binary string. Basically, binary string A and B we have given, and we have to do the sum. Let's try to understand first. So if we have given two binary string, let's suppose this A and B, what does it mean? It means each string contains only here is 0 and 1, right? So 0 and 1 are two binary bits, we can say that here we have, and our task is to add these binary numbers, and we have to return the binary string here, which should also contain 0 or 1 only, right? So the very first thing we should understand is what is a binary, right? Binary is base 2, if you remember, right? They should have the base 2. Okay, basically this is called base 2. If you write 0, if you write 1, if you write 2, if you write 3, it represents some number. So 2 to the power 0 itself say 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is what you call is 8, right? Like that we can say that, like we have. So this is called the base 2, and binary is a base 2, and there is only digit allowed is either 0 or 1, in the form of 0 and 1. So if you want to represent any binary number, right? So we know that the formula we have is 8421. Based on that, you have to convert in all only digit with the 0 and 1. All zeros should be 0 and 1 only. How? Let's try to understand here. If you have 1, you will add the formula over here is this will be 1 and the rest will be 0. So we'll say 0 0 0 1, or basically people also say 0 1, right? Or only one digit is also saying that. Okay, if you have 2, you will say okay, this will be positive and the rest will be 0 0. So it will, this time it will become 0 0 1 0, and some people also saying 1 0, right? Like this for the 2 digit. It depends on till the 2 digits we only count 8421, something like that, right? If we are having 3, you will say okay, this will be 1 1 and this will be 0 0, or you can also say 1 1, like this. So basically the decimal digit, but we have to take a carry at the sum too, right? So let's try to understand what I'm trying to say here is, if we have a example, let's call I want 1 plus 1. So 1 plus 1 is 1 0. Okay, because 0 written, right, and 1 is a carry, means 1 and 1. If we'll do this, it become 1 and 1 is 0, and this 1 will be get carry here. So 0 is written but 1 is carry, or carry is 1. So this is called carry, right? Similarly, if I want 1 plus 1 plus 1, if we will want this one, or we can say 1 plus 1 plus 1, what is the value here? So we have to take, this is 1 and 1, we have seen that we have got 1 0. Now if I'll do plus 1 here, so 1 0 1 and 1 1 is 1, there is no carry. 1 is written, carry is 1, we already have carry 1. So in this case you will get 1 1, right? So we should understand these type of things, that binary is base 2, there is only one digit allowed, that is either 0 or 1, we can say, and only digit allowed if 0 and 1, like decimal addition, but we have to carry, but carry happens at sum 2, right? Sum equal to 2, we can say. But for example, we have seen that if we will use 1 plus 1, how this carry will happen. So when we do 1 plus 1, we have written 0 and 1 become a carry. Similarly, if we do 1 plus 1, we already know this result is 1 0. If we want to do plus 1, means 1 we have to write as a return and 1 as a carry. I hope you understanding these things, right? It's very easy. You have to just understand. So that is called binary. Now think that if we have a two input string, let's call A and B we have, right? So if two string we have as a given input, so what the output should be here? A string representation with their binary sum. So we have to take the binary sum, and that binary sum will give you some result. That result you have to return as a output. Okay, this is what the question is saying. So I hope you have understood this part. Like we have one we have given, right? And we want one. And we already know that if we'll do 1 1, we have to write 0 and 1 will be carry. Then 1 will be carry means what? There is already 1 is already here, and there is one more 1 is there. This 1 we will add, we will get 0. There will be 1 carry again, right? So this carry we have to add. That is why it is having 100, right? Now understand this one, 1000. Let me clean it. Now think that we have given this part, right? Means we have given 1 0 1 0, and this is given is 1 0 1 1. If we have aligned like this, and if I want to do plus, right, means we want to add from right to left, right? So we will go from here. So 0 and 1, how it will work? So let's think that we have something here very important to represent. Like if we'll represent 0 1 2 3, so let's call this as a index. Okay guys, so if it is index and we want to do what? We want to do sum, right? So let's start from index 3, right? Or better, we cannot write like that. It's my mistake, guys. So let's suppose the index we will start not from that side. It basically will start from 1 0 1 2 and 3, like this, right? Index. Now think that if we want to do the sum, right? So we'll start from index 3 itself, right? So 0 and 1, this is the rightmost we have, and 0 and 1, we know that if we will add 0 and 1 as a plus, so what should be the value? We know that carry we don't have here, so carry is 0, we can say that, but the result is 1, right? 0 and 1 is 1, so we'll add here 1, no carry is here. Now we have 1 plus 1. We know that if this is 1 and this is 1, 1 plus 1 is 0, and carry will be 1 here, right? And then we will add 1 0, right? So basically we have seen that. Let's write like this. Okay, something we have to write different. Let's suppose that we have, we call that the very first step is we have 1 0, right? 0 plus 1, right? 0 plus 1, we have seen that carry is 0, and we are talking about this one, right? This carry is 0 and result is become 1. So next time we have is 1 and 1 at a step 2, right? 1 plus 1, we know that there is this will become what? 1 plus 1 is nothing but 2, so this will become binary 1 0, right? This is binary. And if we'll do 1 plus 1, so this 1 plus 1 is binary representation. This take 1 as a carry, and 0 we have to write here, right? We write 0 and 1 is carry. So the now result is we have 1 here, and this is 1 0, right? So what is the result here? Now the result will become is 0 1, correct? Now step 3 we have is we have 0 0. So 0 0 we will take 0 plus 0 is we don't have here anything, but we have carry is 1, because when we are doing 1 plus 1 0, very first become 0 and this 1, right? It become 0 1, right? So the carry was 1 there. We'll take, we have to do plus 1 carry, this is plus, okay, carry was 1 already, so we'll say 0 0 and this is 1, okay. So we have to write 1 here, so result is become 1 here. Basically we have to write 1, right? Carry is 0 here, so previously was this one, so total become 101, we can say that directly, 101, right? Now we have 1 1 again, so let's write here as a 4, and we call this 1 plus 1 is 2, and we'll say this as a 1 0. Now carry is 0, carry is 1, sorry, write 0, so this will become what? It gives you the result with the previous one is already we have 101. Now we'll write 0 first, so there will be 1 carry, right? 1 carry is there, it means further if you'll write this, it become 1 again on the front, and 0 1 0 1 will be there, okay. So final carry will be added here. It means if it represents, so this 0 1 become 1, then we have 1 and 1 is 0, there is no carry, so we'll write this 0, but there is 1 carry. Now 0 0 is nothing but 0, but we have 1 carry, so we'll write 1 here. Now we have 1 1, we will write 0, but there will be 1 carry will be there, so 1 again we'll write 1 here, so this will become the final answer here, and it is matching, right? So basically our approach will be, let's suppose if this is A and this is B, so we want to start from the very first the last index, we can say is I and J will start and will keep moving in the left side, right? So we'll use the 2 pointer I for A and J for B as a 2 pointers, and we'll keep moving each step in the left side for moving ahead. So basically the intuition we have is, this is a problem, is simulation problem where we will do the manual binary addition, right? As we have seen in these 4 steps. So the pattern that we are going to use here is binary 2 pointer approach, where we will use from left to right, we'll keep going, sorry, right to left will go, and we'll carry the handles, right, each time. So the best approach is to use the string builder here for this approach, because we have to our 2 pointer will keep moving from here, right? It will keep moving like this, right, in the right to left, and there will be some carry will be each time will be there, and that carry we have to handle. So use a string builder for the efficient string construction. So why the 2 pointer will work here? Because binary addition start from LSB, right, least significant bit rightmost, we can say that from here, and strings are stored in the left to right, so we traverse backward easily, right? So every steps what you need to do is, basically the core idea is, if you say is for every steps, right, what you need to do, you have to find the sum, right? So sum is nothing but the bit from A, we can say, and plus the bit from B, and if there is some what you call carry is there, so we'll take a carry. So 3 things we have to take: bit from A, bit from B, and the carry, and that will be nothing but your sum. Then only you need to think about the, let's call the digit, right? So if you have digit, let's suppose, how we will find the digit? So you will get some sum, right? If we'll take the with 2, we will get some digit here, right? So this mod will give you the digit, and if you want to find the carry again, because in each step we will need the carry, so we'll say, okay, what is the carry now? You just need to do the sum by 2, you will get the carry. Like that we have to keep moving, right? So basically if we want to start, you will start I at from the last. Let's suppose a dot length will be there, -1 will go, and j will also start from b dot length -1, and you will start coding. Let me show you the code. Okay, so we know that we need a string builder, right? And we have a and b, so we'll use the two pointers a and b, and there will be some carry will be there, right? Now what you need to do is, let me zoom out a little bit. Okay, so very first what you need to do is you will start I and j, and you have to go from, we are going from the last length, right? Means let's call, in this case we have 3 as an index, and so we'll start I and j from 3, and I will be go till greater than equal to 0, means 3 to 0. It means I and j we have to do minus minus, right? So check, if you see minus minus, we are doing I and j. So in all the cases, and carry should not be equal to, not equal to 0. In that case, we have to find int sum equal to carry. We have to start from the carry, and we know that there will be some character will be there. We check with the value a dot char at I equal to -0, means we have to add digit from a, and we'll do the sum. Again we'll do the same thing with the b, because the let's suppose both the binary number will not be equal. That is why we have to take each character, and we have to add on to the sum. Okay, so each time you will do minus minus, and then you have to add, you have to append the result sum. In each step you have to add on to the result. Now we have to update the carry. So how will you update the carry? So carry will check sum by 2, and you will update the carry as we have seen. Now we have to go the reverse, because we added the LSB to MSB. So you just need to do reverse, result dot reverse, and you need to do toString. And this way we can solve this problem, right? There are some other approaches also, right? You can try, like this is the main code we have, guys, right? Basically the approach we can use is alternate approach that we can use, which is not recommended, guys. We can convert the integer, right? And let's call integer dot pass. You will pass a comma 2, right? And b comma 2 you will do, like that you will do. The problem is that we will overload for the large input string up to 10 to the 4 length, we can say that, which is not allowed in the real interview. So try to use this approach, because that approach will take uh, space for large inputs, right? And you can also use the bit manipulations in the recursive way, and you can try by yourself. Okay, in case if you need help, you can ping me in the comment box, and I'll put this code into the our comment section. You can get from there. And please like, subscribe, and support ExpertFunda in case you are new. Otherwise you are doing all the way. So thank you guys, thank you for watching this video. I'll see you in the next one. And for any preparation, you can join our online classes. You can contact us to do the preparation and structured way of learning. Thank you. Bye bye. I'll see you in the next one.